Hey, g'day, it's Brezzo here. Thanks for joining me in the workshop today. This is part 8 of building the Mixie Steampunk digital clock. And if you've missed the first 7 episodes, I've got a playlist. There's a link on the screen now if you'd like to go back and look at the rest of those. But today is all about making 2 parts for the clock, one of which is just decorative, the other one is a practical part that we need for some operation of the clock. So the first one we're doing here is called a discombobulator. Now it's just like I say, a bit of whimsy really. We've got a turned brass part for the base. There's a glass tube cover to go over the top and a copper coil goes inside, and it's illuminated from underneath with a single RGB addressable LED. You can set the color of that particular LED to whatever you want in the software, and it's going to be supported by a copper tube with a couple of screwed fittings at either end. Now the other part is a more practical part. This one I'm calling the cyclops eye. Now it's just a brass base with a clear acrylic dome inside that, and fitted into this drilled hole is going to be a light dependent resistor. Now this is used by the electronics in the clock to set the clock to night mode. So the display itself is fairly bright, and if this was in a bedroom it'd keep you awake all night. So in the night mode the display is set to like a dull magenta color, and although that can be set up in the software as well. Now we're going to make some copper tube fittings to support these 2 parts we're doing today, with some hex fittings on either end, and we'll look at that later. And then I'm not going to talk about this too much, I'm just going to get on and do it. So let's head over to the lathe and get started, and we'll come together at the end and just talk about winding up the video. Okay, let's go. So with that part that I just cut there, that's 3mm clear acrylic, and it's got two holes, 1.8mm diameter on the software, but this is 1.7mm diameter copper wire, and that's sort of a reasonable fit in there, and that will form the copper coil that goes inside the glass tube. And with the LED, it's got two surface mounted devices, one either side of this raised square window, and that's what these engraved pockets are for, either side of the cut hole. And when that's inserted, if I can get it, goes in neatly like that. We need to have 3 wires soldered onto the back of the LED, and everything will get bonded together with some cyanoacrylate, and then we can get on and assemble the whole thing. So let's go and do the copper coil. I've got to make what is basically a copper spring, and this is some 1.7mm diameter copper wire, and I took this out of some household electrical wire, and I'm going to straighten this before we go over to the lathe and make the spring. So I'm going to show you an easy way to straighten copper wire, or any soft wire for that matter. So really what you want to do is just get the wire and put it in the chuck of your cordless drill, and then anchor the other end in a vise and just stretch it lightly and twist it. Probably only need about 3 or 4 turns depending on the length of the wire. So let's go ahead and get that set up. Alright, lightly stretch it. That's it, dead straight. Now of course, don't overdo it because you will shear the copper right off. So in order to anchor the end of this copper wire, I've just bent the end at 90 degrees, and we just slip it into the chuck jaws. And I'm gripping the other end of the copper wire with a pair of pliers just to keep some tension on it. And I've got to get about 20 turns on here. Righto, here we go. And if you're doing this with springy wire, just be careful when you release that. So there's our coil, but I want to open that out now to make it look more like an open spring. So I want to stretch this to be about 90mm long when it's opened out. That's not bad. That's about right. I'm going to have to just dress this a bit, try and get the coil sort of evenly spaced. I think we're pretty good. And then we're going to bend this end down, and it's got to end up on the opposite side to this piece of wire here. Alright, so that's the arrangement there, and it's going to bend this end 90 degrees to come down opposite this other piece of copper. So now we got that, and that should fit inside our glass tube. So what I'll do is get all this tidied up and sort of get everything straight, and this can be anchored to the little acrylic disc we've already cut on the laser. It's going to go about there, so now we can just snip off the excess wire. So when this is finally assembled, we're going to bond the copper to the acrylic with some cyanoacrylate, and the glass tube will fit down flush with that acrylic disc there, and the LED will be bonded on underneath there. So that's it, looking good. That pocket that I've drilled in the end of that lens there is for a light dependent resistor, and that'll be used to set the night mode for the clock. And when you look at that from the front, the end of that drilled hole is a bit scratched and a bit gnarly looking. But I'll use some ethylene dichloride solvent in that hole there, and that will smooth out some of those scratch marks. Oh, really? Come on. Come on. In one of the previous episodes I said I'd show you how to make these copper pipes and the fittings to go with them, or at least how to join them together, and that's done by silver soldering. So I'll make up this one here, and I'll do one of the smaller diameter pipes at 3/16. But I think in episode 6 I was having a general whinge about having to use LPG or propane to make these joints, and there's a limitation on how much heat you can put into a part with propane. Even if you've got fire brick, you know, it's a limit on the size of parts you can do. So let me show you what I bought. And here it is. Now, one of the reasons why I didn't go with oxyacetylene in my home workshop is that the cost of renting 2 D-size cylinders is fairly expensive. And here in Australia, there's really only 2 options. You can either rent cylinders and you pay an annual rental fee whether you use the gas or not, or you can do a swap deal where you buy the cylinder up front and then you take it back when it's empty and they swap it for a full one. Now, BOC Gases have a sort of a deal running at the moment. They're doing a rental plan for home shop or home workshop owners, and it costs around about $79 a year per cylinder, and like I say, you pay that whether you use it or not. Now for me, I don't use this a lot, and it's cheaper for me to actually do the swap system. So I think I paid $279 for that D-oxygen, and when I take it back empty it costs around about $90 to $100 to get the swap. And I already had LPG or propane here in the workshop because I use that in my metal melting furnace for home casting work, and I'm hoping to change over to a diesel powered furnace burner, so I really won't need this for the furnace anymore. And a friend of mine gave me this Comet 3 handpiece and the cutting attachment and all the blowpipes. The only thing it didn't have was the hoses and the LPG regulator, and I bought that in a kit. So I think I got this from Hamden Industries, and it was around about $200, and I got 3 of the cutting attachment tips as well. Standard acetylene cutting torch nozzles won't work with LPG. So my friend also gave me this second-hand oxygen regulator. So all in all, I'm super happy with it, but I'll show you in a minute one of the downfalls of working with LPG. Well, here's the biggest problem. Now, I bought one of these piezo lighters thinking this would be preferable to a flint lighter, and it's absolutely useless. So I cannot get that propane to light at all using that. And I think it might be because the spark is either too cold or it doesn't produce a spark that's long enough. With the regular flint lighter, the gas pools in that little cup underneath there and ignites fairly easily. So yeah, it gets us back to the flint lighter. But the other problem with LPG is that, if I can get that to work. Yeah, alright, that's why I don't like flint lighters. Alright, that's the other problem. You can see how the flame burns right off the tip. Now if I open the oxygen now, it'll just blow that flame right off the flame zone and it won't burn at all. So you've got to reduce the size of the flame until it burns back onto the tip, then increase it again just slightly, and then very slowly open the oxygen. And if the valve is tight, which it is, and there we go. So you can see it's starting to burn off the end there again, and you just got to play around with the velocity of that flame until it sticks to the end of the tip. Alright, oxygen coming on now, and we bring that back to a neutral flame, and then you can increase the fuel and then once again bring it back to a neutral flame. So it's a little bit trickier to work with than acetylene, but the flame it produces is super hot, and you can concentrate the flame in a very small area, which you can't do with propane. So I'm just going to do these 2 joints here on this 1/4 inch copper pipe. So I've already got flux on there, everything's clean. And it would be possible to completely melt these parts if I'm not careful. So there we get the red heat there now. And that's it, that one's done. That one's done. So yeah, super quick. So I'm going to go and put that in the sulfuric acid to pickle that and clean up the flux, and then we'll do the other smaller part. This smaller diameter pipe, which is used to mount the pressure gauge and the discombobulator, is made from 3/16 diameter copper tube. I bought this stuff already annealed. It's not perfectly straight, but it doesn't need to be. And I 3D printed a tube bender, and that little hook holds the tube in place, and the moving die comes around and will just form that around the groove in the edge of that part. So let's see, alright. So we just sort of pull that around. And there's our bend. Now I'm going to cut this off to length. It's just 30 millimeters from the back of the straight to the end of each section of pipe, both ways, and we'll get the fittings on. Now I'm just going to light this up, and every man and his dog's out here mowing at the moment because the rain is finished and the grass is growing like mad. So I'm just going to talk over the top of our neighbour's mower. The other thing about this flame is that determining when it's neutral is a bit harder than with the acetylene. You really don't get 3 distinct cones. So that's carburizing, excess fuel. That's starting to come to neutral, but like I say, it's really hard to tell. That's definitely oxidizing. So I'm thinking that's probably neutral there. Oh, well, that's done, and thanks to all the people that commented and suggested that I try Oxy LPG. Really didn't consider it an option up until this point, but I'm super happy with it. So yeah, thanks. Oh, just before we wind up today, I thought I'd show you some of the parts, and these are now pretty much ready to fit to the clock. So here's the copper tube that we made up earlier. It's been cleaned in sulfuric acid to remove the oxide and also the remainder of the flux, and those little coupling nuts will hold that in place. Now luckily these don't need to be steam tight, so it's really just a method of fixing it to the dome of the clock. Now here's the LED. Now I've already bonded that to that acrylic part that I cut on the laser. You can see that there, and I've soldered on the 3 wires that are needed to illuminate that LED. So there's I think the yellow one is positive 5 volts, the blue one is negative 5 volts, and the green one, through some devil magic that I don't understand, is what's required. That's actually the data line. That sets the colour and the brightness of the LED. Now I just put some 2-part epoxy on the back where those solder connections are, so it won't short out when it goes into this turned brass base. So that will just simply push down in there, and then our copper coil that we've already made, that'll get bonded into the pair of drilled holes like so, and then over all of that we're going to fit this glass tube. Now you can buy these glass tubes from woodworking suppliers. I think they're sold as bud vases, but I actually stole this one out of that toy meth lab that I bought for my nephews and nieces. No, that's not true. And the 3 wires go through that copper tube and they'll all get held together. Right, there you go, that's assembled more or less now, and that'll have to get fed through the steam dome down into the body of the clock. Okay, now for the other part, this is the light sensor. Now with that acrylic lens, you remember when I drilled this, it looked all scratched at the bottom of that hole there, and all I did there was I put in a drop of ethylene dichloride, which is the solvent that acts on acrylic, and that sort of chemically polishes the bottom of that drilled hole, and when you look at it from the other side now it looks a lot neater. The LDR will fit into that drilled hole. That's a 5.1 diameter drilled hole. That'll get bonded in with some epoxy, and that fits into the brass base we've already made. And that's sort of just a press fit. I don't think you'll need any other sort of solvent or anything to make that fit tightly. And there's our copper tube, once again all cleaned up, and that part's ready to go. So that's it, folks. I'm going to wind up here now, and in the next episode we're going to come back and do the acrylic screen for the clock, and we might start on some of the finishing processes, so some of the powder coating and the lacquering of the wooden parts. So join me for that. It should be a ton of fun, and I look forward to seeing this lit up. And quite honestly, I haven't seen it lit up yet. I just haven't got to that point yet. But that's going to be for the reveal when we're nearly finished. Okay, it's Presso signing out. I'll catch you on the next video. Thanks for watching.